Hey YouTube, how is it going? I hope all is well. Today we are ready to test this thing, make sure it's ready to go, get it biased up, or at least test our bias, make sure I was correct on my guesstimation there, and actually make some sound through this amplifier. I like doing these, finishing up videos as part of the build series just because it's an important part of actually doing the amp, and I have a little bit of a different way of doing everything. But first and foremost, you should always have a drink of choice within arm's reach at all times. Today, we've got Dr. Pepper, 23 flavors that are pure bliss when it hits your lips. I am for hire. Anyway, I apologize. I am doing things a little bit differently. I'm standing up and talking into a microphone. Doing this is not exactly easy with something in front of you. So I am not monitoring myself today. So if it sounds a little weird here and there, I apologize. And life being what it is, things have to get done. Yes, you can hear the drying, the dryer in the background there. My apologies. I'll try to make sure I speak up and make things as clear as I possibly can. So, first things first. No tubes are in the amp. This amp has not been on. Yes, I can touch things, and yes, I can get. I do the work with. I'm going to say do a lot today too. I do work with this ring on my hand. I mean, you really would have to goof up to get. You'd really have to goof up to get that thing to touch anything. Interesting thing. This build series was posted in a forum, and the only question the guy had was whether or not I was going to be testing and working on this thing with a ring on. Yes, I don't understand. Like, that should not be what you're worried about. You should be worried about how you're going to win this thing. I did get some traction last night. Some people have posted some answers. There are some new hats, or new names in the hat, excuse me. So, yes, it's going to start getting interesting, and I'm going to have to start doing some work. I should also clarify that beyond just answering the questions and stuff like that, you do have to be a subscriber. So if you're not already subscribed and you want a chance at winning this thing, you've got until 8 o'clock tonight, because I'm going to post this thing here in the next hour or two probably, or hopefully within the hour or two. So this will be out probably tonight before the things end for yesterday's query. You had some test questions that you had to answer, and you have to tell me. You have to answer those test questions, so you do have to pay attention to these videos. But you do also have to be a subscriber in order to put your name in the hat. I should have clarified that yesterday as well. But we're going to make things interesting. It's not always just going to be test questions. There are going to be things you have to do. All right, so we need some tools, though. We're going to need a pen. Obviously, our tubes are going to be ready to go. They're not in the amp yet and have not been in the amp yet. And then you're going to need some paper and a pen, right? So first things first, you need to test this thing and beep things out. So we're going to take our digital multimeter, DMM as I call them, and we're going to put it into beepy beepy mode. So it's, I don't know if you can hear it. Let's make it so you can. Right? Click and beep, right? So we know that it makes a beep sound. What you want to do is go through your schematic and make sure that everything that is supposed to touch does touch. So things like this here. That there. Okay, yay. This should go to there. No, not to there. One of these. There it is. And then the other one comes to that one. There it is. All these things here, right? Right, you're just going to go through, you're going to beep everything out. You're going to make sure that all your connections going this way and that all are doing what they're supposed to do. I mentioned the other day that you can also check to make sure that your volume controls are going to work by taking and turning them all the way down. So when they're all the way down, they should beep when you touch it to ground. And it does, right? Beep. And then as soon as you lift it off of 0, it should no longer beep, and it does not. Same with this one. So if I go to ground, you can hear it beeps. Well, maybe you can, maybe you can't, but I can hear it. It beeps. And as soon as you come off, no more beepy beepy. So our volume controls are working like they are supposed to. All of my connections are where they are supposed to. We should be good to go in theory. So let's get this thing kind of centered up there. I'm going to go ahead and leave those there. I'm going to turn up the bass and treble all the way. And I'm just going to leave the voltage or the volumes kind of where they're at there. We'll put them like that. We know that they're there, right? It's a real show now. You're welcome. Excuse me, that was rude. Dr. Pepper burp. If you want the real burps, you got to get the Dr. Pepper. All right? Remember, 23 flavors that are pure bliss when it hits your lips. Okay, so we are now ready to turn this thing on. All right, so this is where it starts to get real. You're no longer going to be able to touch these things with your bare fingers anymore. All right, so from now on, things are going to get real. But first, let's do one more measurement. So I mentioned you're going to need a piece of paper and a pen. What we want to do is get the measurement of our output transformer from its center tap, which is right here, to each of the plates, okay? This is a number that you can write down and hold on to for the remainder of the life of that transformer. Start in the lowest ohms reading that you have, and you're going to touch in on the plates, or the center tap side of things, and then you're going to go to one of the plates, or one of the primaries, if you will, and you're going to come up with some number. It should be pretty low, usually right around 100 ohms or so. It just depends, right? Usually within a couple hundred ohms at least anyway. So 71.6 is what we're going to say this one is. So we're going to write that number down. So we're going to write 71.6. We're going to do the same thing for the other side. So put that there. There's a piece of paper. Center tap. Plate. And we're going to end up with some other low number. And in this case, it's 74.1. They will never be exactly the same, and a little bit of difference is okay. So 74.1. I'm going to write that down. All right. So now you've got these numbers written down. You're good to go. We'll come back to those numbers in a bit. All right. So now that we've done all that, we're ready to actually plug this thing in and start doing some dirty. So we're going to take our power. We're going to make sure that the amp is in the off position. It is. We're going to plug it in. Now, this is the point everybody cringes. Usually people use a dim bulb or a variac or something like that. I'm not into that kind of crap. There is no reason to fear turning this thing on if you know that you did all your stuff correctly, right? Repeat after me. There should be no fear turning this thing on if you've done everything correct. Hence the reason why you want to have clean wiring, that you want to check all of your work several times as you go through and at the very end, especially at the very end before you go to turn it on. If you've done all of that stuff correctly, there should be no fear to hit that switch right now. Now, I don't believe in forming on these things here. I can tell you right now that everything in your house, your computer, your refrigerator, your microwave, your television, whatever, if it's in your house and you turn it on the first time you get it home, that's the first time that thing's probably ever been turned on. And if it wasn't, and it did actually go through some sort of quality control before it got to you, I can guarantee goddamn to you, they did not bring it up on a variac or a dim bulb, right? I kind of want to get the infant mortality out of the way right off the bat. I don't know if you've ever heard of it, but it's called the bathtub curve. So, products either fail, electronical components, either fail pretty much immediately, infant mortality, or right at the expected life expectancy of them, right? So there's this large area in the middle where they just operate like normal, but there's a percentage of them that fail pretty much immediately, or they last until they are at their life expectancy. So just be aware of that. I don't believe in trying to give this thing a soft blow. It needs to fire up, and it's going to fire up right freaking now. We have light. All right, so you should already know there are no tubes in here, so there's actually not much going on the HT rail because there's nothing to get there yet, but we're not going to worry about that. We're not going to be touching in there anyway. So we are only interested at this point in time in AC voltages. We just want to know that we have HT coming in from our secondary off of our power transformer and that we have heater voltage. So we're going to put this in AC mode and we're going to put it on the highest voltage rating that it has. We're going to put this into the ground, somewhere where it's grounded, and I'm going to touch each of the red wires down there. And it's going to be difficult for you to see me do that, but I'm going to do it. And I got to contort around this microphone here, so bear with me. There we go. And we're going to come up with some sort of a number. I don't know what it's going to be, but in this case, it's 276. The other side should be the same. 276. What do you know? 276, 276. I think this is a 275 power transformer, so it's right on the money in that regard. Now we want to get, sorry, jumped the gun there. We want to get our heater voltage. Now, you might as well just go to the end of the string and measure it there. Chances are pretty good if you got voltage on both of them there, all the rest of them in the string are going to be just dandy. So we're looking for 3 volts on either side. So we're going to go to pin 9, and we see 3 volts. And then we're going to go to pins 4 and 5, excuse me, and we see 3 volts. 3 plus 3, 6. We know that we got heater voltage in this thing. We are good to go. We're going to turn off the amp. So amp is off. We are going to unplug the power. You might as well turn your DMM off. Unplug the power. We are ready to put the rectifier in this thing. Now, in the case where you have a solid state rectifier, that would be a little bit different because you would have voltages sailing through the entirety of the amp. That's why I was saying that now at this point we don't go bopping our fingers in there all willy-nilly. We want to assume at this point that everything is always on and in danger mode, right? Okay, so DMM. Now everything that we're interested in is going to be DC voltages. So we're going to go to the other side of our multimeter here for DC voltages. Is the one with the solid line and the dashed line underneath it. AC is the one with that squiggly line underneath there, and that is what the DC side looks like. So we're interested in DC, and we're going to set for the highest value that we can measure. We're going to take our power, we're going to plug it in. There it is, and we're going to turn on. This is the amp. Yay. So now we've got a bunch of angry pixies rattling around through this amp here. Again, we're really only interested in a couple different voltages, so we're going to put this on the ground, and we're going to measure in at our first node here. And it's going to be some high number. We don't know what it's going to be yet. It looks like it's just coming up on temp for the rectifier, and we're sitting at 386, 387. That's about what I thought it would be. Ooh, nailed it. Fist bump. And then we might as well just go down to the end and make sure that we got something there. This will tell us that we have voltage through our string, through all of the different nodes, etc., etc. And we can see that we have about the same voltage. We dropped about 10 volts through this whole string. Now what we're going to do is measure the other side of these to check the plate voltage, what it would be. We want to see that there is a small drop, or at least a drop. And that just lets us know that this plate resistor is actually in circuit and doing what it's supposed to. And you can see obviously that it is working as it should. So 360, and if we measure on the other side, which is the side of the B+, it'll be, 380 or something like that. And it will read high initially because there is no load in this thing. Remember, right now there's only a rectifier in there. There are no other tubes. You can actually see my hands, or my fingers, excuse me, through the tube sockets down there. All right, we're going to turn that off. We're going to turn the amp off. We're going to unplug the power. And then we're going to plug in some preamp tubes. And if I line that up right, it'll actually go in. All right. We now have preamp tubes inside of our amplifier. We're going to test again. Same. We're going to go for 600 volts on DC. And we're going to plug in our power. And we're going to turn this turd on. Click. All right, now what are we doing now? What we're trying to do now is to see that these guys are actually conducting. We want to know that our preamp is actually going to make any kind of noise. Now, it's not going to drop a whole lot of voltage from what it was before, but it will drop some amount of voltage. So we went from like 370 or 360 or whatever it was down to about 300 volts. So we've definitely got some current draw on this end of the thing here, on this end of the string. And now what we want to do is measure over the top of our plate resistor there to make sure that we do have a voltage drop. It should be somewhat significant. So you can see we've got about 153 volts there. Not too bad. So we know now that that tube is conducting, and then we do the same for the other one. So we should see a lower voltage on this side than we do on the other. So we have 243 here and 307, so 308, whatever. So we know that these tubes are conducting, right? So that's all we need to confirm at this point, is that the tubes are conducting. We are about to get to our money shot right now. We are going to get to the gold. So we're going to turn the amp off. We're going to unplug the power. And we're going to plug in some tubes, some power tubes. Nailed it. There we go. All right. Okay, so here we are. We're at, for all the tea in China right now at this point. Okay, let's take a little sip to that. Nothing's blown up yet. Okay, at this point, this amp is going to be live. It is going to start conducting. So you need to have a speaker load plugged in. So go ahead and get that done first. Make sure you're on the right ohms tap. I am for this particular setup here. And since we're at it, might as well plug in a guitar. Drink out of the way there. All right. And now we're ready to plug in the power. And we're going to go ahead and turn this thing on. Now, remember these things here. In a moment, we're going to go to a web page, and we're going to double check our bias on this thing. Now, it should be, if you went with like a normal value, like 250 ohm, 250 ohm should be about spot on. Based on my math, I figured I'd be right around 200 ohm, so we're going to find out for sure. It's a real show now. But we're going to find out for sure in a minute. But first, we're just going to turn it on and make sure that it even makes any kind of noise at all. So we're going to turn it on. And we should see that, you know, obviously things are working. We're going to take our DMM. We're going to plug in the ground there. And what we want to see is an actual significant voltage drop on our HT rail. So again, 600 volt DC mode. And if we started at 380, we should end up with some other number. Ooh, we were very close. I figured about 340 to 350, 341. We're pretty dang close. And then at the ass end here, I was shooting for about 250. And we're about 243, 242. So I can tell you right now that this tube is almost all the way at about, it's right around 100% of whatever, plate dissipation. Let's also check the screens. We haven't actually done that yet, but we should probably, that's another spot that you should check. But you can see that the screens here have 296 on one. We should be relatively close on the other, 296 on the other. Perfect. So these tubes are pretty well matched as well. So we now know that this thing should make some noise. There's no reason why it shouldn't at this point. If I can untangle my stuff. All right, so this is for all the tea in China. We're just going to go ahead and take the guitar, turn it on, and make sure we got any kind of noise whatsoever. I hear noise. So that's the gain. This is maxed here. All right, so that works. Let's double check and make sure our bass control works. It appears to be working. Let's check our high cut. That works, obviously. All right, that's with the gain max. Let's do the other direction. So we're going to take up the master volume. We'll kick it back just a little bit. And all right, we know that that works. And this is dimed here, so everything is all the way up. No squeaky squeaky, so it's stable. All right, that is literally dimed everything all the way up. So we're going to go ahead and kick that back a little bit there. So there's that. Obviously, we know that it makes noise. I'm not too worried about that anymore. I don't see any red plating. You should obviously look at that. I mean, you'll know right away pretty much if something's wrong. But I'm going to go ahead and let this thing live in the on position for a little bit. We are now ready to start taking a couple of different measurements. So let's just do the raw, crude, and ugly one first. This is just going to kind of tell us more or less if we're even close to being in the ballpark here. So what we're going to do is put our ground on. We're going to set this for DC again, and we're going to measure our voltage across the cathode bias resistor. So we're going to measure from ground to the actual cathode of the tube, and we're going to come up with some rando number. So in this case, it looks like 17, so that's lower than 200. So let's go ahead and down a little bit. 17.3. Let's go down one more because it's just under 20. And we can see that we're at 17.27. All right, 17.27. That's what we're going to say is our drop across our cathode bias resistor. It's just a rough number right now. We need one other number, though. We need our plate to cathode voltage. So plate to cathode means exactly that. So we got to go from literally that point there to our cathode there. So this one involves getting two hands inside of the amp, so you do want to be careful. Never mind me while I get that done real quick. And yes, it will pop. So you can see we've got 321 volts. Don't worry about the minus number there. It doesn't matter. All right, so we have 321 volts. So we're going to write that number down. Actually, we're going to write both of those numbers down. So we had 321, and then we also had 17.27. So we're going to write those two numbers down. There they are. We know that they're there. Those are going to become important here in a momento. So I'm going to take you over to the desktop here. And we're going to go to Rob Robinette's tube bias calculator page, and we're going to do some work here. So this is let's just go ahead and hit refresh on this here. There you go. Yeah, the freaking ads. Just can't win with the ads these days. All right, so we want to select the tube that we have. I'm using a JJ6V6S, so it's a 14-watt tube. We're going to hit that. We had 321 volts on our plate to cathode voltage there. We're going to hit that. We have two tubes sharing a 200 ohm resistor. So we're going to make that 200 ohm. We're going to hit calculate. And then we had 17.27 volts. So we're going to put 7.27 and we're going to hit calculate. And dang, if I am not a freaking genius, we are spot the heck on, right at 100%. Now, why are we not actually at 100%? And I'll tell you why here in a moment. So remember we took a voltage reading off of the screen grids? Well, the screen grids are actually included in this number right here, okay? So the screen grids might draw 2 to 5%, something like that. Let's just say 2%, even on the low end. So that means this thing is actually only dissipating at about 97%. That's why I usually shoot for right around 95%, and I err to the high side on these things, these cathode bias. This is not referring to a fixed bias amp at this moment in time, okay? So for cathode bias, you want to bias at idle, so not while playing, at around 95 to 100%, I think. Now, even if you do it the crude way that we just did here, and you're right at 100%, do remember that the screen grid is included in that, and that is the total dissipation through the cathode, not the actual plate dissipation that you're seeing on the other end. So this tube is probably actually running closer to 95%. And we're going to confirm that here in a moment. But we know that we're in the safe realm. We're below 100%, more or less. So we did good in that regard. So now let's figure out how to actually figure out what is flowing through this tube. So we're going to cruise on down here. Same page, just cruise on down. And you're going to see here how to measure bias. This is the output transformer resistance method with a typo in there even. Ristacne method. But just know... Ooh, the dryer's finally done. Yay. All right, I'm going to turn that down a little bit more. Okay, so we're going to measure the center tap to the plate. So this involves getting your fingers down inside of the amp again. So it's a little bit brave, but it's nothing worse than the others. This is going to be a much lower number, but start on, again, the highest voltage that there is. So we're going to go literally from the center tap, which is our B+, our first node in the B+ thing, and then we're going to go to the plate of that tube. So let me take you back to camera view here, and I'm going to show you what I'm talking about here. So you're going to take your DMM, and we're going to start in our highest range, and then we got to go from our B+ node, which is that guy right there, to one of our plates. So we're going to get our hands in there, okay? So don't be afraid, just be careful what you touch. And we're going to have some number. It's going to be a low number, don't worry. So it's 3 volts. It's really, really low. So let's just take this down to 20 and do the same thing. So it's 2.87. So let's write that down. 2.87. We're going to do that to the other side as well. So we're going to put 2.87. Now let's figure out what the other side is dropping. So I'm going to just go straight down to 20 there, and I'm going to do the same thing on the other side. .11. Close enough. It's within a volt. It's really close, to be honest. So 3.11. All right. Now we're going to do some maths here. So let's get this thing kind of there. I know you can't really see it because of the white. But, okay, so let's go back to the other way. So we're going to go back to our desktop here. And all we do is take that voltage drop and we divide it by our resistance. So what is that? So let's just do the math on that. So our voltage drop is 2.87. So I'm busting out my calculator here. So 2.87, and we're going to divide that by 71.6. And we're going to come out with 40 milliamps. Right on the money, 40 milliamps. We're going to do the same thing to the other side. So 3.11, and we're going to divide that by 74.1. And it's 41.9. It's basically 42 milliamps. Right close to it. So let's write those numbers down as well. I'm going to do that real quick. I'm sorry you can't see me at the moment. So it was 41.9. And then the other one was, I believe it was right at 40. It was like exactly 40. Okay. So now that we've done that, let's go back to me because it's all about me. So we're going to go back to camera view here. And we can see here, based on the math, that we took that number there, divided it by that number. We took that number, divided by that number, and we end up with that. So we're really sitting right about 40 to 41 milliamps of current. So now that we know that, let's go back again to the desktop. And we're going to go up. And we're going to kind of look at a couple things here. So we could see here that our plate current per tube is 40.8. If we average it out, it's roughly 40 to 41 milliamps per tube. You can see here that our 100% safe max is 43.6. And what do you know? 95%, 41.4. We are literally right at about 95%. So we are sitting at literally 95% of dissipation on our output tubes, which means that 200 ohm resistor is perfecto. We do not need to go any further. I did everything correct. My math was good. My plate voltage is a little bit lower than I was shooting for. I was hoping to have about 350 volts on the money at that first B plus node, but let's go back to our camera view here. I'm going to go ahead and turn this off for now. But yeah, just to kind of pinpoint on a couple things, I was shooting to have about 350 volts there. We ended up at about 340 something, a little over 340. So I was within 5 to 10 volts there, so that's good. Over here, I was shooting for about 250 volts, and it came out about 242, 243, whatever the heck it was. So we're really, really, really close. I mean, that's within a small margin of error, right? So this amp is doing everything that it's supposed to do. I can already tell just from what I've done that I am going to be putting a treble peaking cap over the top of the volume control. I want it to be a little bit brighter when it's in the clean mode, and when it's cranked all the way up, it's not too bad. I mean, you heard it with the tone knobs dimed, and it's a little brash when it's all the way up. Some of that could be the cabinet choice that I've got going on back there. Some of it is obviously that there is no tone control at this point in the amp when it's turned all the way up like that. So it's going to be whatever it's going to be. So I am not really set up at the moment to play anything, but let's just go ahead and turn it back on, and let's just make some noise. We're just going to make some noise. We're going to futz around a little bit. So I'm going to move the mic a little bit. Turn down the bass just a skosh. Working. I think we get the idea. It makes noise. It's working. Obviously, you can't see me right now, so it's already pretty boring. I'm going to call it good. We are going to replace that resistor now with... Is this the right one? That's a 300. This is a 250. I need to find a 200 ohm of one of these. Whoop. And I don't know that I have one. There's a 300. There's a 250. I need to find a 200 ohm of one of these. I don't have one of those in 200 ohm. So we are going to get one of those. in 200 ohm, and then we will replace it with that. No, that pile of crap is not going to stay in there. So there you have it. We have ourselves a working amplifier. It is biased correctly, etc., all the fun, good stuff. So we're right at about the 35-minute mark. We've done pretty good. I'm going to put this in the general, well, yeah, I'm going to put this in a couple different playlists, but because this is kind of an educational one, as well as being part of this build series here. But I didn't want to turn this build series into like a 10-parter, but we're getting ready to do the woodwork, so we need to put a cabinet on this thing. So let's unplug this a little bit, though, and make it so you can see it a little more. And no, I'm not going to have any tests in this video here, so this is not, there's no points to be had in this particular one. So there it is. So we can see here, this is what we end up with. And obviously, you know, I've got the protection stuff on there. So, but there's our amp. I almost got this thing spot on. I need to adjust this thing a little bit more. Bane of my existence, those things. I'm very persnickety about that kind of stuff. I like things to be straight. So we'll work on that a little bit more. But yeah, we've done good. We've done good. We've done good. So I do want to thank you all so much for all your support. Somebody's going to be super duper stoked, I think. I don't know really what a 5E3 sounds like, but it sounds pretty much like any 5E3 I've heard on the interwebs. So with that, thank you so very much. We'll see you in the next one. Take care. Goodbye.